Welcome back, student, to my YouTube channel KP Pharma Corner, and I hope you all students are doing well for the preparation of GPAT, and I wish you all the best for your preparation. Today in this video we are going to see that how to prepare for pharmaceutical chemistry from the GPAT point of view. So in GPAT, organic chemistry is a very important, and in the recent examination, if you see the questions, then there are so many direct questions are asked, and also there are some indirect questions are asked. So while doing preparation of organic chemistry for GPAT, so what point you should consider? So you have to consider before the preparation. So you have to remember the substrate of any reaction. So what is the substrate? Then you have to remember the reagent. You have to remember the catalyst. Then the solvent for the reaction. Then intermediate and the stability, because stability gives a orientation of the product. Today in this video we are going to focus mainly on these 5 rearrangement. These are very important, and we will also see the questions related to these rearrangement reactions were asked. So first is a Wolff-Kishner reduction, second one is the Clemmensen reduction, third one is a Beckmann rearrangement, then pinacol-pinacolone rearrangement, and next is a Baeyer-Villiger oxidation. So before starting this video, dear student, I am going to bring your attention on some important aspects of reaction, because reaction is nothing but a simple equation in which substrate plus reagent that brings a stable structure that we called as a product. So here you student must have understanding of identifying the substrate from the given reaction. Once you identify the substrate from the reaction, then so many questions will be easy. Then you have to identify the reagent, because reagent determines the type of reaction, whether it is oxidation, reduction, or what type of electrophilic or nucleophilic substitution or addition reaction. Then product is nothing but a stable organic structure, and that cannot further interconvertible to the other structure. So we can conclude that yes, reaction is get end. So product is nothing but it is the end of the reaction. Before understanding the reaction, we are going to focus what is the meaning of substrate. And dear student, substrate is an organic compound. It is a organic compound, and this organic compound has a unique group that we called as a functional group. And in the substrate is a structure where the chemical changes are occur. So where these chemical changes are occur, so chemical changes are occur in the functional group, and therefore you have to identify which functional group has a more priority, which functional group is a more reactive over other, so that you can easily identify the product, what product is going to be formed. Then next is the reagent. So dear student, there are mainly two types of reagent. First is a nucleophile and second one is a electrophile. So nucleophile, if nucleophile is going to attack on substrate, then we called it as a nucleophilic addition. And if that nucleophile replace certain group, then we can call it as a nucleophilic substitution or a replacement reaction. Likewise electrophile. So nucleophile is nothing but the electron reach center and generally carries a negative charge. And these are the electron reach and generally attack on electron deficient center. And electrophile is nothing but it is a positively charged and it is attack on electron rich center. So this is what the difference where these two reagents are going to be attacked. Dear student, in organic chemistry there are certain name reaction and that name reactions are generally identified as a unique feature of using particular reagent, whether it is nucleophile or electrophile. Okay, and these electrophile and nucleophiles are generated from the compound which is inorganic in nature. So it is a inorganic compound. So reagent is nothing but the inorganic compound from which this nucleophile and electrophile is generated, and this electrophile and nucleophile is going to attack on functional group of a substrate, and substrate is an organic compound where the chemical changes are occur. So dear student, while there is interaction of a reagent and substrate, there is a formation of some transition state, and their stability of transition state gives the direction of formation of the product. So dear student, you have to consider this while studying. So here we are going to focus on certain name reaction. So the reactions are named because these are not ordinary reactions. These are the unexpected reaction. Whatever expected product we people want, but this reaction gives a different types of products, and that's why scientists did their contribution over understanding the nature of the reaction, how the product in this reaction are formed, and therefore these reactions are named. For example, here Wolff-Fresnel reaction is there, but it is a type of a reduction reaction. Then Clemmensen is also the type of reduction reaction. So in this video we are not going to cover all the rearrangement reaction, but yes, the student can get a very easy idea that how to understand organic chemistry from GPAT point of view. Then few rearrangement reaction like a Beckmann rearrangement, then pinacol rearrangement, and then Baeyer-Williger oxidation. So here, as I told you, while studying rearrangement reaction or any name reaction, you student, while reading your reference book, you have to keep a note on what is the substrate of that particular name reaction, what is the reagent used in the reaction, then catalyst. Along with the catalyst you have to consider the reaction condition, because in many reaction there is a heat is required. In many reactions the reactions proceeds at a room temperature or at a cold condition, the products get differ or get oriented. Then intermediate, definitely the intermediate, their stability is important in order to find the order of product formation. So which product is a form as a major or which product is a form as a minor product, that can be understood by understanding the stability of reaction intermediate. So first of all we are going to focus today on Wolff-Fresnel reduction. So dear student, reduction is a simple reaction where the addition of hydrogen is takes place, or reduction is the reaction where addition of electron is takes place. So addition of electron is nothing but the reduction. This is in terms of the exchange of electron, but in terms of exchange of hydrogen or oxygen, we can say that reduction is the addition of hydrogen. So here you have to focus on this is a substrate. So substrate consists of a functional group, as I told you. The substrate here is a organic compound and the functional group inside it is a aldehyde or ketone. Dear student, this Wolff-Fresnel reaction is very simple, in which the reduction of aldehyde and ketone takes place to form a simple alkane. It means that instead of oxygen there is an addition of hydrogen, and therefore the conversion of carbonyl compound to the alkane is takes place. Okay, then if you see the reaction condition, then there is a use of NH2 NH2 in the presence of a mild alkali, and very important, you have to note down this, that utilizes a heat. Okay, and in presence of heat and mild basic condition, this reaction proceeds the reduction, that is the conversion of aldehyde to the ketone. So the use of hydrazine, so if you found hydrazine along with the carbonyl compound, so carbonyl compound along with the hydrazine, so you have to directly understand the reaction is a Wolff-Fresnel reduction. And the very importantly, this Wolff-Fresnel reduction is mainly used for the reduction of only and only aldehyde and ketone in presence of basic condition, with the application, with the aid of certain amount of heat that produces the alkane. And this is what the reaction intermediate, as I told you, that is the formation of this hydrazone is the reaction intermediate inside it. So one thing I am going to note down in front of you, that while studying the organic chemistry or the name reaction from the competitive examination point of view, so you have to understand first what is the product, from which substrate what product is formed, and second thing, you have to understand what is mentioned on arrow, that is what is the catalyst, what is the reagent in the reaction. So as I told you, reaction is a simple equation in which a substrate react with a reagent to form a product. So just try to identify what is the substrate, what is the reagent. So here this aldehyde is a substrate and this hydrazine is a reagent, and that hydrazine gives a hydrazone, so that is the intermediate. And here this inorganic compound, that is a potassium hydroxide, is called as a, that is a reaction condition in which this reaction is proceeds, and that is the stable alkane is a stable, that's why it is a product. So here you have to note down that this reduction is takes place in a basic condition with the aid of heat. So try to predict the product. So for example, this is a cyclopentanone. So this cyclopentanone is treated with the hydrazine, then it produces the cyclopentane as the product. And here there is a carbonyl group, and here it is a carbonyl group. You have to just convert this carbonyl group into the carbon-carbon single bond, or instead of hydrogen, instead of oxygen, you have to add the hydrogen. So let us take the answer, that is a conversion of a carbonyl compound or the carbonyl functional group to the alkane. So these are the answers. Then second is the Clemmensen reduction. I bring this Clemmensen reduction for the comparison with the Wolff-Fresnel reaction. And yes, one student can do the preparation by comparing the two reactions which are very similar, and one can note down the difference point among the reaction. So Clemmensen reduction utilizes a reagent, that is a zinc amalgam in presence of hydrochloric acid. So this is also a simple reduction reaction. Here it is also a conversion of a carbonyl compound to the alkane. So it is a alkane, or you can say that it is a saturated compound, carbonyl group to the alkane or saturated compound. So zinc amalgam is the unique reagent that can identify the reaction, and in the previous reaction we use the hydrazine, and hydrazine with carbonyl group, the reaction will be the Wolff-Fresnel, and this zinc amalgam with the carbonyl group or the carbonyl compound, the reaction is called as the Clemmensen reduction. So in this reduction, so one student can identify that it utilizes the acidic condition. So acidic condition is required in Wolff-Fresnel reaction. it requires the basic condition. So you have to identify or you have to compare this reaction likewise. Then this is an example where benzaldehyde is treated with this zinc amalgam in presence of hydrochloric acid. Then there is a simple formation of this methyl group to the benzene. So benzene alkanes are formed. Then here it is a ketone is treated with a zinc amalgam. It gives a addition of hydrogen, that is conversion of this carbonyl group to the alkane. So let us compare this reaction and you have to do some notes on the reaction. So what will be the points you can identify? That Clemmensen reduction uses a catalyst called as a zinc. So however, no catalyst is required to perform the Wolff-Kirschner reduction. So Wolff-Kirschner reduction, what is the Wolff-Kirschner reduction? So there is a KOH. So KOH is the reaction condition. So it is not a catalyst. So in this case, so zinc is used as a catalyst. So likewise you have to identify. So the question will be asked, which of the following reduction reaction utilizes the catalyst? So zinc is the catalyst, and in the Wolff-Kirschner this hydrazine is not a catalyst, it is a reagent. Okay, so likewise you have to do the you have to make your own notes. Then one more thing, that is a diethylene glycol is a commonly used solvent for Wolff-Kirschner reduction. So you have to remember the use of solvent, that is diethylene glycol is a use in a Wolff-Kirschner reduction. So why it is used in a Wolff-Kirschner reduction? Because that solvent is necessary if we are going to add some amount of heat. So if you add the heat, then it requires some solvent, and yes, this diethylene glycol is used. So that is what the reason. Then Wolff-Kirschner reaction generally requires a high temperature to produce, to proceed. So here this is a Clemmensen reduction and this is a Wolff-Kirschner. So you have to check that there is a no addition of heat. So heat is not added, and where it requires the heat. Both reaction gives the similar product, that is the alkane is the end product. Both reaction has the same substrate, that is the carbonyl compound is the same for the both reduction reaction, but the differences are one utilizes the catalyst, one not using the catalyst, whereas Wolff-Kirschner reaction requires the solvent, whereas this zinc amalgam, that is a Clemmensen reduction, does not require the catalyst. So dear student, likewise you have to categorize this reaction. So I compare here the two types of reduction reaction, and this question you have to consider from the point of view of GPAT examination or any other competitive examination. So how you are going to compare? So just look at the product. One is a Clemmensen product and another one is a Wolff-Kirschner product. So accordingly that you can differentiate these two reaction. Yes, that our main focus of this both the reduction reaction is the carbonyl compound. So both carbonyl compounds undergoes the formation of product, means both undergoes the formation of saturated carbon, or the alkane is formed in a place of this carbonyl group, but simultaneously you have to consider what the other changes are takes place, and that is very important part while studying the organic chemistry for GPAT, that is the use of hydrochloric acid in a Clemmensen reaction that gives the substitution reaction. So this is a side reaction occurs, and due to this substitution reaction, this OH group is replaced by this chlorine atom. And yes, this is completely absent in Wolff-Kirschner reduction, because this Wolf Krishna reduction use a basic condition, and that basic condition cannot be suitable for the replacement of this OS group, and hence likewise you can compare. So here I given one example of comparing the reduction reaction. Likewise you student can compare any two reactions, which may be the oxidation, which may be the rearrangement reaction likewise. So next is a Beckmann rearrangement. So dear student, there is a direct question were asked on the Beckmann rearrangement in GPAT 2023. The question is related to the migration of alkyl group to the electron deficient nitrogen. So which so how the migration is takes place in what type of nitrogen, whether it is electron rich or electron deficient, that type of question was asked. So here, so conversion of oxime to amide is takes place. So here oxime is given. So what is oxime? It is a nitrogen and OS group. So it is called as a oxime. When ketone is treated with hydroxylamine, it produces this oxime, and when this oxime is treated with the H2SO4 in presence of some aid of heat, it gives a amide. So this is a amide group, and that's it. This is a very simple reaction. Only the conversion of oxime to amide. So what will be the points of study from the GPAT point of view? So here oxime is used. So oxime, yes, there may be the chances of syn oxime or anti-oxime. So anti-group migrates over syn group. So here student can learn what is the syn group and what is the anti-group, and that will be the question for the GPAT examination. My dear student, in GPAT examination, no question is repeated. The syllabus is the same, but day by day, number of questions are generated, because it needs a study, it needs a detailed understanding of the concept. You student should create your own question bank for the GPAT, solve amongst the students, that will make a better preparation of GPAT. So here the what is it is given. So anti group migrates over syn group. So here what is the anti group in oxime? So let us understand. So this mechanism part is a very similar that you learn in the theory examination, but here from GPAT point of view I am going to bring your focus on syn and anti group. So here azobenzene for example. So what is azobenzene? So two benzene ring groups are attached to the azo group. So azo is a carbon double bond, sorry, nitrogen double bond, nitrogen. So here it is a trans isomer. So why it is trans isomer? Because in azo or in nitrogen, student has to understand the presence of lone pair of electron. So this lone pair of electron creates some steric hindrance and creates some geometrical differences, and therefore we can get a geometrical isomer of azobenzene. Likewise here in this Beckmann rearrangement, so oxime is used. So there are two types of oxime, one is a aldoxime and one is a ketoxime. So in aldoxime there is a syn oxime and one is a anti-oxime. So what is meant by anti-oxime and what is meant by syn oxime? So dear student, here it is a nitrogen and there is a lone pair of electron, and that acts as a fourth group, and here it is a OS group, and these both groups will never get changed. These are the fixed group in the case of aldoxime, because aldehydic hydrogen is important, that will not be changed, and here the lone pair of electron and oxygen, this will not be changed. But what is going to be changed? So the change is only the changing is only this kind of group. So you have to see the position of this group or the position of this hydrogen. So listen here, if the position of this hydrogen and this oxime OH group, if it is on the same side, then you have to consider this is as a syn oxime. And here, if this aldehyde hydrogen and this oxime OH group, if they are in opposite direction, if they are in opposite side, then you have to consider this as a anti-oxime. So here in this case, in this rearrangement, what is the statement? The statement is anti-group migrates over the syn group. So here you know that what is the anti-group and what is the syn group. So here you came to know that what is the syn group. So syn group will not be prefer for the migration, whereas anti-group get preference over the migration. So here again, likewise aldehyde ketone can produces the oxime, so called as a ketoxime. So here syn and anti can be applicable, but here this OH group along with the highest priority or the bulkier group, for example comparing ethyl and methyl. So ethyl is a greater group or more preferred group. So if it is on the same direction or same side to this OH group, then we can say that it is a syn ketoxime. And here this first priority group, that is ethyl group, is on opposite direction to this OH group, that is oxime OH group, then we can call it as a anti-oxime. So here student must know what is the ketoxime or anti-oxime, what is the aldoxime, what is the syn-oxime. So let us check. So here what will be the product? So the simple reaction where the migration is takes place. So migration is takes place from this anti side. So this is a OH group. So here it is a OH group and migration is takes place from this side. So here the reaction is very simple. If there is a methyl group, so what will be the product? So you have to just understand migration is a preferred from anti side. So this OH group is on another side and this methylene group is on another side, then the product will be like this. So here it is a formation of this methylene group will migrate instead of migration of this group. So likewise you can solve such a kind of a tricky questions by understanding some basic concepts in the chemistry, because the questions are always asked related to it. So next is a pinacol rearrangement. This pinacol rearrangement was asked in GPAT 2023, and what it is nothing but a conversion of vicinal diol to the ketone. So what is the meaning of vicinal diol? So vicinal diol is nothing but a diol having adjacent or the carbon having adjacent OH group. So it is a diol. So in this reaction, so protonation takes place to the carbon, generate more stable carbocation. So dear student, there are two OH group. So the question is which OH group undergoes protonation first, either this one or this one. So the concept is what? You have to understand which protonation generates stable cation. So you have to check this carbon, which carbon is a more stable, and there is a migration as it is a rearrangement reaction. So the migration is takes place in the pinacol rearrangement. Then you have to understand the migration aptitude, that is hydrogen will take place first. So listen, hydrogen has a first priority, phenyl has a second, and then alkyl, and out of this alkyl tertiary, secondary and primary. So remember this migration aptitude also. So you can get few more points in this slide, that is a preference. Okay, so here there is a OH group, there are two phenyl rings, and here it is a two hydrogen, so which undergoes first protonation. So the protonation is takes place to the carbon, which generate more stable carbocation, and therefore this takes place a faster, whereas this gives a slower rate. My dear student, in the next video we will give more focus on many more reaction, and because the length of this video becoming more, and that's why we are going to stop here, and I hope you will immediately join in the next video with the new reaction. So I hope you enjoy this video. If you have any doubts, comments, you can put in my comment box. You can mail me with this email ID, and thank you very much.